Okay, so I'm going to show you how to solve the focus for series circuits. So first, we know that it's a series circuit because it says it up here, but how do we know if it is a series circuit? Well, if the resistors are connected in order, like in one loop, and there's no branches, there's only one path for the electrons, that means it is a series circuit. So if it's a series circuit, that means there's specific equations that we use to go along with that. So here's the reference table on page 4, and if we get down to this midsection here, we see that there's series circuits and parallel circuits. Well, we already established this is a series circuit, so these three equations are going to be our friends to solve this. And then we're probably also going to need to use Ohm's law, which is this one here, because that equation is just so useful all the time in solving circuits. So I'm going to come back up to the top here, and I'm just going to write those equations down. So we had series circuits. There was the Req equals R1 plus R2 plus R3. There's I equals I1 equals I2 equals I3. And then the voltages, V1 plus V2 plus V3 equals V total. And then, of course, our Ohm's law, which was R equals V over I. Again, a lot of us like to use the triangle method for figuring out how to solve this. So that might come in handy later. Okay, so the first question, so it says this one is 4 ohms, this one is 1 ohm, and this one is 2 ohms. We have a voltage of 3 volts. And it's asking for Req, so find Req. So if we're looking for Req, we're going to use this equation here, which is nice because it's just addition. So that means we're just going to take Req equals 4 ohms plus 1 ohm plus 2 ohm. And guess what? That gives me 7 ohms. So that is the answer for this first part. Great. And then we are going to move on to 2, where it asks for voltage and current. So here we want to be a little strategic. We want to figure out what's the best thing to solve for, voltage or current. And the way we're going to look at that is we're going to look at these equations over here again, and we want to solve for the one that gives us the most information. So if we solve for one of them, we solve for all of them. And in that case, that's going to be current for series circuits, because everywhere in the circuit, it has the same current. And the reason for that is because there's only one path for those electrons to go. So there can only be one current. So again, if we solve for one of them, we solve for all of them. So let's do that. But wait, how are we going to do that? We can't use this equation here because it just says all the i's are equal to each other, but we don't know a single one. That's where we're going to use our Ohm's law. So if I want to solve for I using this little thing, that means I is going to be total voltage, divided by total resistance. I don't know why it keeps doing that. So I'll just write it down here. I equals V divided by R. So in this case, my total voltage is 3 volts divided by 7 ohms. And when I do that, I get 0.43 amps. And I'm just going to round to the hundredths for this case. So that is my amps. And again, because I solved for the current here, the current everywhere is going to be that. And that's going to become really useful for us later. So I'm just going to fill all those in like so. Okay, then to find voltage, we're going to have to use Ohm's law again. Let's see, I'll pick orange. We're going to solve for voltage. And if we're going to solve for voltage, we're going to have to use if we cover up the V up here, we see that V equals I times R. So in this case, we know our current because we just solved for it. And the resistor, so we don't want to use total resistance in this case because it is asking for at R1. So my resistance at R1 is 4 ohms. And when I multiply those together, I get 1.7 volts if I round to the tenths. So that is 1.7 V. And we're going to do the same thing for part 3. We already know the current, so I don't need to do that, but we have to do V equals I times R, which again is going to be 0.43 amps times the ohms at R2, which is 1. Oh, that's convenient. So that's going to just be 0.43 volts. So that's the answer for here, and I'm just going to put it in tenths just to keep it consistent. And then for 4, same idea, V equals I times R, in this case still 0.43 amps, times my ohms, which is 2 ohms. And then when I multiply those together and I round it to the tenths, I get 0.9 volts. 0.9 volts. Now when we add all these up, it should give us 3 volts, and it looks like it does. So, ta-da! This plus this plus this equals 3 volts, which is exactly what this equation here says. All right, so at 5, what is the voltage there? Well, it's at point D. It's not a potential difference over a resistor. It's just, you know, a piece of wire. There isn't a potential difference drop. There isn't a change in the energy. So the voltage is actually just going to stay 0 volts there, and then at point D, the current is still just 0.43 because there's still electrons going through at that point, but there's no voltage being used. Okay, so that's how you solve a series circuit. You're going to need to practice this a few more times until you're totally comfortable with it, but that is how you do it. All right.